Before the forest wakes, there is another world, a secret kingdom woven from threads of silk and adorned with the morning's first jewels. Each strand, a marvel of engineering, is strong yet impossibly fine, transforming simple dew into a dazzling spectacle of refracted color. As dawn's light reveals this hidden architecture, we enter the realm of the spider, an ancient builder whose work begins before the first bird sings. The story of spiders begins deep in Earth's history. Encased in this golden tomb of fossilized resin, we have a near-perfect messenger from a world lost to time. This is not just a preserved creature, it is a window, a direct portal to an epoch so distant it challenges our comprehension. For nearly 400 million years, the ancestors of today's spiders have been scuttling across the face of our planet, silent witnesses to the rise and fall of empires, the shifting of continents, and the reign of the dinosaurs. They are true survivors, pioneers who mastered their craft long before the first flower bloomed or the first bird took flight. To understand the spider of today, we must first journey back to a primordial Earth, a planet that would be utterly alien to our eyes. This was the Devonian period, the age of fishes. But on land, a green revolution was underway. Vast, humid swamps choked the equatorial regions. There were no birds, no mammals, no reptiles. The air, thick with oxygen, was ruled by giant insects. Dragonflies with the wingspans of hawks patrolled the skies. The forest floor was a damp, mossy carpet, dominated by colossal tree ferns and primitive, spore-bearing plants reaching for a hazy sun. It was in this steamy, formidable landscape that the first arachnids made their move from water to land, and among them were the creatures that would lay the groundwork for the entire spider lineage. These were not yet true spiders, but their close cousins, the Trigonotarbids. They shared the characteristic 8 legs and predatory nature, but lacked 2 key features that would define their descendants: venom, and most importantly, the ability to spin silk from spinnerets. Their abdomens were heavily armored and segmented, a relic of their aquatic ancestors. They were ground-dwelling hunters, ambushing other early arthropods in the damp leaf litter. They were a successful design, thriving for over 100 million years, but they represented a biological dead end. The future belonged to a different branch of the family tree, one that was developing a secret weapon. That weapon was silk. The earliest spiders emerging in the Carboniferous period possessed a revolutionary anatomical innovation: spinnerets. These specialized mobile appendages at the rear of the abdomen could manipulate and extrude liquid protein, which hardened into silk upon contact with the air. Initially, this remarkable material was likely not used for capturing prey. Instead, it served as a protective lining for burrows, a soft blanket to swaddle precious eggs, or as simple tripwires, alerting the hunter to nearby movement. It was a tool for safety and sensing, a way to shape and understand their immediate environment. But evolution is relentless in its opportunism. As life took to the air, so did the spider's ambition. The Carboniferous skies were buzzing with newly evolved flying insects. This was an untapped 3-dimensional hunting ground, a buffet of protein just out of reach for a terrestrial predator. Silk was the answer. The first webs were likely not the elegant orbs we know today, but rather crude, horizontal sheets or funnel-shaped tangles stretched between low-lying vegetation. They were simple, yet utterly transformative. For the first time in the history of life on Earth, an animal had created a tool to extend its senses and its grasp far beyond its own body, passively hunting in a dimension it could not physically occupy. The aerial web was born, and the world would never be the same. This ancient blueprint was astonishingly successful. Spiders survived the Great Dying, the Permian-Triassic extinction event that wiped out over 90% of all marine species and 70% of terrestrial life. They watched the dinosaurs come and go, surviving the asteroid impact that ended the Mesozoic era. While other dynasties crumbled, the spiders endured, adapting and diversifying. Their small size, cryptic lifestyles, and mastery of silk allowed them to weather cataclysms that felled giants. The spider we see today, crawling through the leaf litter, is a direct descendant of these tenacious survivors. It carries within its DNA a 400-million-year-old legacy of resilience. From that ancient foundation, an incredible evolutionary radiation occurred. The simple sheet web gave rise to a breathtaking array of designs: the iconic orb web, the chaotic tangle web, the ingenious trapdoor, and the single-line casting net of the bolus spider. They have conquered every continent except Antarctica, from the highest mountains to the deepest caves, and even the surface of freshwater ponds. Each of the nearly 50,000 known species today is a variation on that ancient theme, a unique solution to the universal challenges of survival, hunting, and reproduction. They are a testament to the power of a single revolutionary idea, the architectural marvel of silk. Silk is the spider's signature. For a web builder, the hunt is silent. Not all spiders build to hunt. Jumping spiders are vision-driven hunters. Among spiders, some fight for survival through beauty. In Australia's grasslands lives the peacock spider, a tiny artist whose life depends on its performance. To court a female, he raises a spectacular, iridescent abdomen, a hidden fan of breathtaking color. He begins a complex dance, waving his legs in a hypnotic rhythm, but the female is a harsh critic. If his display is flawed, he won't just be rejected, he'll become her prey. The night belongs to the builders. Not all webs are wheels. In the grand, intricate tapestry of life, there are threads of influence so profound they defy belief. Consider this staggering fact. Spiders, the silent architects of the undergrowth, consume more insects in a single year than the total weight of all 8 billion humans on Earth combined. It's a statement that borders on the absurd, yet it's a conclusion backed by meticulous scientific research. Annually, the global spider population devours an estimated 400 to 800 million metric tons of prey. To put that into perspective, the entire human population weighs approximately 400 million metric tons. This means that every year, spiders collectively eat at least their own weight in humanity, and possibly double. They are, without exaggeration, the most significant and voracious predators of insects on the planet. This isn't just a curious piece of trivia, it is a cornerstone of our planet's ecological stability. Without this relentless global-scale predation, the world as we know it would cease to function. Their impact is felt most acutely in the control of populations that directly affect us. Take the mosquito, carrier of malaria, dengue fever, and Zika virus. While we deploy nets and repellents, spiders are waging a silent, 24-hour war on our behalf. In wetlands, forests, and even our own backyards, their webs act as indiscriminate, highly effective traps. Each mosquito ensnared in a silken prison is a potential vector of disease neutralized, a tiny battle won in a global conflict for public health. The same is true for countless other insects we consider pests. Flies, which can transmit pathogens from waste to our food, are a staple in the diet of many common spiders. Moths that would otherwise lay waste to stored grains and fabrics meet their end in a silken shroud. But perhaps their most vital role is one that goes largely unseen. They are the unpaid, unsleeping guardians of our food supply. In the world of agriculture, spiders are indispensable allies. Fields of corn, wheat, and cotton are not just crops, they are ecosystems teeming with herbivores. Aphids, caterpillars, grasshoppers, and beetles can decimate a harvest, leading to billions of dollars in losses and threatening food security. While humanity has turned to a chemical arsenal of pesticides, spiders offer a natural, sustainable alternative. They patrol the leaves and stalks, selectively removing the very insects that would consume our crops. Their presence reduces the need for chemical intervention, which in turn protects pollinators like bees, preserves soil health, and prevents toxic runoff from contaminating our waterways. They are a form of biological pest control perfected by 400 million years of evolution. The methods by which they achieve this monumental feat are a testament to nature's ingenuity. The most iconic strategy is, of course, the web. It is not merely a trap, it is an engineering marvel. A spider's silk is, pound for pound, stronger than steel yet possesses an elasticity that allows it to absorb the kinetic energy of a flying insect without breaking. The classic orb web is a masterpiece of geometry and physics, a passive net that uses vibrations to transmit information. The spider often sits patiently, one leg on a signal line, feeling for the telltale struggle of ensnared prey. But this is just one design among thousands. Funnel web spiders construct silken tunnels, rushing out from their retreat to ambush anything that trips the lines at the entrance. Sheet web spiders spin dense horizontal mats, trapping insects that fall from the vegetation above. Each web is a different solution to the same problem: how to efficiently catch a meal. Yet nearly half of all spider species have abandoned webs entirely, opting for a more active, confrontational approach. The jumping spiders, with their astonishingly acute vision, are the cheetahs of the micro-world. They are intelligent hunters that stalk their prey, calculate distances, and launch themselves through the air in a precisely aimed pounce. On the ground, wolf spiders are relentless pursuit predators, running down their victims with speed and power. And in the blossoms of flowers, the crab spiders wait in ambush. Masters of camouflage, they can change their body color to match the petals, remaining perfectly still until an unsuspecting pollinator comes within reach. From passive trapping to active pursuit and stealthy ambush, the diversity of their hunting strategies allows them to exploit nearly every terrestrial habitat on Earth. Their ubiquity and efficiency lead to a sobering thought experiment. What would a world without spiders look like? The consequences would be nothing short of apocalyptic. Within weeks, insect populations would explode to unimaginable levels. Swarms of locusts and caterpillars would trigger global famine as they consumed our crops unchecked. The hum of mosquitoes and flies would become a deafening roar, and the diseases they carry would spread like wildfire, leading to pandemics on a scale we cannot comprehend. The ecological cascade would not stop there. The countless birds, lizards, and even fish that rely on spiders as a crucial food source would begin to starve. The intricate food webs that support our ecosystems would unravel. The world would become a landscape of decay, disease, and starvation, all because one small, eight-legged predator was removed from the equation. So the next time you encounter a spider, whether in a pristine forest or the corner of your room, it is worth pausing to reflect. We are conditioned to see them as monsters, as alien intruders in our world. But the truth is, they are not the monsters. They are the guardians who protect us from a far more chaotic and dangerous reality. They are the silent, tireless regulators of our planet, the architects of an invisible kingdom that underpins our own. Their work ensures the balance of nature, the health of our crops, and the very air we breathe. They ask for nothing in return, only that we allow them to continue their vital, ancient work. For many, the sight of a spider triggers an ancient, primal fear, a deep-seated instinct to recoil. But this reaction often clouds our judgment. Yet for all their ecological value, spiders remain profoundly misunderstood. A closer look reveals not a monster, but a creature of intricate design and delicate features. They are shy architects, preferring the quiet shadows to confrontation. Their world is one of peaceful existence, far removed from the terrifying myths we've created. From giants with legs spanning dinner plates. Spider silk is nature's blueprint for the future. Every web is a story written in silk, an artistry that predates humanity by hundreds of millions of years. This is not mere thread, it is a biopolymer marvel, a liquid crystal that transforms into a solid fiber stronger than steel, yet with incredible elasticity. Within the spider's body, specialized glands concoct a variety of silks for unique purposes. Tough, non-sticky dragline silk for the frame, fine, fluffy silk for swaddling eggs, and the capture silk adorned with microscopic droplets of glue, a fatal necklace for the unwary. The tale begins with a leap of faith, a single thread released into the breeze. Once it catches, the architect begins its meticulous work, a dance of instinct and physics. It drops, climbs, and measures using its own body as a ruler, calculating tensions with astounding precision. This is not just a trap, it is a sensory organ. Every vibration travels along these silken pathways to the spider's waiting legs. The world for a spider is not seen, but felt. The web is its window, its telegraph, and its dinner plate. The construction is a masterclass in efficiency. Nothing is wasted. The initial, non-sticky guide spiral is consumed by the spider as it lays the final deadly trap, recycling the proteins. This cycle of creation and conservation is fundamental to its existence. Once the final strand is in place, a profound stillness descends. The architect takes its position in the central hub or a nearby retreat, a single signal line connected to the web's core. Here, it waits, a portrait of patience. The web, now complete, is more than a structure. It glistens with morning dew, a tiny suspended oasis. But its primary function is far more dramatic. It is a stage, meticulously set for a life and death play. The first actor often arrives by accident, a fly buzzing through the undergrowth, failing to perceive the near-invisible strands. The impact is gracefully absorbed. The capture spiral, with its incredible elasticity, stretches to cradle the prey and dissipate the kinetic energy of its struggle. The vibrations of the trapped insect are not chaos, they are a symphony of information. They travel through the radial lines to the spider's 8 legs, sensitive listening posts that can discern the prey's size, location, and potential threat from the tremors. In an instant, the patient sentinel becomes a lightning-fast predator. It moves with terrifying speed and precision, its goal to subdue the victim quickly, minimizing damage to the web. The spider delivers a bite, injecting a complex venom. This biochemical weapon paralyzes the insect but also begins digestion externally, as powerful enzymes liquefy its internal tissues. With the victim immobilized, the spider performs its final act. Using its hind legs, it deftly pulls sheets of swathing silk from its spinnerets, wrapping the prey in a silken shroud. The fly has now become a neatly packaged source of protein, its energy ready to be transferred up the food chain. This transfer of energy is the engine of life. The nutrients from a single fly will fuel the spider for days, converted into the energy needed to repair the web, survive, and produce the next generation. The female channels this energy into hundreds of eggs, protected in a silken sac woven from the bodies of her victims. But the spider is not the apex of this miniature world. The hunter is also the hunted. A spider wasp, a formidable predator, does not seek to eat the spider but to use it as a living incubator for its young, paralyzing it with a sting. Birds too have learned that a web's hub signals a protein-rich meal, and a swift attack can end the spider's story in a heartbeat. Even the elements are a constant threat. A heavy downpour can shatter the delicate architecture. A strong wind can rip it from its moorings. The story written in silk is often ephemeral. When a web is destroyed, or when the spider meets its end, the cycle continues. The spider's body decomposes, its nutrients returning to the soil. The silk itself is consumed by bacteria and fungi, its molecules recycled back into the ecosystem. Nothing is truly lost. This intricate dance has been perfected over 400 million years. The ancestors of today's spiders were among the first creatures to walk on land, spinning silk long before the dinosaurs, a legacy of survival and adaptation. Now, we are learning from this ancient master. Scientists study silk, hoping to replicate its properties for revolutionary materials, like lightweight armor and surgical sutures. This humble spider, so often feared, holds the blueprint for future innovations, reminding us that profound solutions are often found in the time-tested designs of nature. The web is a microcosm, a perfect illustration of the interconnectedness of all things. Each strand is a relationship, each vibration a piece of information, each capture a transfer of energy. To look closely at a spider's web is to see the universe in miniature. It is a lesson in engineering, a saga of survival, and a meditation on the delicate balance between life and death. A story of how the smallest among us play a vital role in the grand narrative of our planet.